I want to point out a few things. The first thing is this an end item, say that's 737 model 700, for example, and then a structure under this. This is quite common, and you find it in manufacturing, bills of material, etc. What is new in the concept I'm talking about is that they put a zero item on top. And what they do, they put all requirements coming from the client, but also from laws and regulations, etc. Everything they're coming from outside. They call it the application requirements. That's their choice of words. And this is telling what the product must do. And on this question, the product must do, the supplier or the vendor comes with an answer what the product can do. And this is a very clever plan. If you see a lot of contracts, this is mixed. And in a mixed contract with application requirements and the answer, you build in a lot of open items, unknown open items, and they only cause trouble in the project. That's not, you need a lot of flexibility to solve them, but that's not the kind of flexibility I prefer. I like flexibility only in the way of real improvements, not something that we could have seen in front. The answer says, okay, what can the product do? A functional specification. How does the system, the technical system, do that in system schematics? How does the product look like? There can be layout, there can be BIM model, there can be everything, and how it's built in main lines. This is the answer to what he says over here. And this way of thinking should be on every border, what you can see as a buyer and a vendor situation. So for buy items, you should do the same for this item with your supplier for that. That's a very clever thing. The other thing I want to tell is, I already did, consistency. The very important thing of consistency. If you change something here, that means that everything should stay consistent. So this doesn't give the answer, but this helps you very much to judge if I change this, what has to be changed as well. And probably here's something, a little more, this probably will not be affected, and so on and so on. And no document management system will help you to find this out. That's the second thing I want to tell you. And the other thing, we said we are not only looking to design and engineering, we are also looking to asset management and operation, etc. because people get on changing products. At the in design, engineering, manufacturing side, we end this configuration with items that are going to be built, because the configuration from the item to be built is somebody else. It's a problem, and by in the case of operations and repair, etc., we are ending with a buy or replaceable item. There where nothing is repaired but the whole thing goes out and a new one comes in, we end our configuration. I think I had my 3 points, so I go further. Product structure. This is a moving baseline. Who of you knows about baselines? No one?
You heard what PMI baseline?
Baselines?
Scope management?
Oh, okay. A baseline is a form of bill of material with some more data that shows what is in exactly what is in the product. Normally we use in practice there are fixed baselines on certain milestones of the product. You have a design baseline, you have a concept design, what is in the font, you have engineering baseline, what is going to production. Many times production has their own baseline, the manufacturing baseline, and so on and so on. But the disadvantage from fixed baselines is you don't know the actual situation between these points. CMT has the idea of only one moving baseline, and the moving is that they put from every document they put the plant data in the baseline, and also the release data. So you see, and all documents have been identified before. They can be empty. What I told the real content is never in the document. The real content is in a document version. The version has the document, and you will see everything over here. You see when it's planned, you see when it's released, and you see when it's, oh, it's still the Dutch word, but when it's effective. And we have to introduce a new thing. I will come to that. Effectivity. Who knows the word effectivity? 1, 2. Effectivity is the moment in time when a change is effectuated, when a change goes in, when the new changed item is getting in used. So it's not the release date when the document is released, it's the date when the manufactured item is taken in place. That's the only effectivity that CMT knows. I have also been involved in other effectivities, and that's an effectivity is a machine serial number. For example, you make planes. Every plane got its own machine serial number, kind of ID, just number 1, 2, 3, 4, etc. It's a sales number. So if you see a plane with MSN 140, you know it's a 140 plane of that type. But then you have also an effectivity. Then you have a generic configuration of all the types, all the 737-400, and you have options or alternate. You have special things, and these are effective for the machine numbers 15, 17, 23, and 31. That's also an effectivity. These both are used, but for the individual configuration per plane, you still need the date. These are the two things, and you can have much discussions about it. But let's see what is. If you see the baseline in a computer, it's the point you always have the latest one, and things that are deleted are out of sight. They're still existing, but out of sight. What is in it? We have a column for the item. The item, you see the level of the item, so it helps you to understand the structure we saw before. It has the ID of the item and then a description of the item. And then you get all the documents related to the item, and the document has a type, the document has an ID, the document has a version, very important, the version, document version, that's where the content is. It has a plan date, it has the highest authorization is given here, So things can always find back from which decision, why, etc. It has what is it? It has a plan date and when it's a release date. And then about changes. A change, there is a engineering change note and enterprise change note, we call it now. That's mentioned, this document is due to this order, and the effectivity is given here. And we will say on that date, this document goes in and another one goes out. So when we come, so the whole collection of all the documents in this will give you the actual status at any moment of the project. And therefore, if you put a paper out of it with a certain selection, the baseline doesn't get only a date, it has also a time. Better is not to take the paper out with a look on the screen, then you're all sure you have the latest situation. This happened to be perfect to keep the total overview on the project. And if plans are changing, it's not forbidden to change, but you just can do it, and you can compare with all the versions of all the dates and times what has been changed. And in that sense you can also control or you are behind total schedule or not or whatsoever. So this about the moving baseline. If you never heard of the other ones, I would say forget them and try this. The baseline. Cornerstone to release the release process. So I first try to give a very clear understanding what the release process is. I take as example, I'm writing a letter to my grandma, just below a goal, but anyhow, what do? I write the letter, then I judge the letter, I'm just looking at the language I use or she will understand it, and okay, I agree, I make some changes and get the next iteration, okay, letter ready, and I take responsibility for what I've written and I sign it. So I see what I do see here. I see what I say natural 3 steps. I create, I judge, and I take the responsibility, or I release it. I have 3 rows, only 1 person, so this is never a problem. It goes automatically. Now, project situation. On the house in 3, there's an author who creates this drawing. And it should be judged and approved by several experts. The city authorities have something to say, or you can have this thing. There's a guest house in your garden. There's a structural engineer who has to say, or it doesn't fall down, everything is strong enough. There's a material consultant who will tell you, or you use the right materials, etc. And there's an installation guy who says that it's not, that doesn't matter. And then there is a project manager who takes the responsibility for the total project. What do I see? I see the same roles, but there are many persons doing it. This is what we find back in the release process I propose. So this is the basic again. We have an engineer making the drawing. We have a number of experts telling or things are good or not good, and we have the authority that releases, and then there is, it comes later, there's an auditor who judge or the game is played as it was intended to play. So you don't find the release process in the CM2 thing. This is what I put in. This is what I learned in my experience and come finally up in the early 90s with this release process. There's one step, creation is still there. I put the second step in place for information, for observation and comment only. And this means that, we see it later. This is a second step. It's not natural, but it's put in the system. There is the step we already spoke of, judge and validate the several aspects. Then there is a step we will mention here and then forget it. It's released for dedicated action. For example, the example of making a new door for an aircraft engine. The tool to make this door is taken a number of months to be delivered. So I don't want to wait till everybody is ready with this design. I go from, I suppose it's not changed anymore, and I order the door. In this special case, the humidity was changed, so pity then 80,000 kilos were gone. But that's we have to remember this. I come later back to that. That is released for dedicated action, and then the final step, I release it for every following step. Now in a picture, what's going to look like our release process. I have the guy making the requirements, making the document, the version, and at the time he thinks it's mature enough to show it to his colleagues. And these observers, these are all the engineers involved in the project. And when he thinks it's mature enough, they get a note and they get access to look into his drawing, and they can comment. It's not, they don't have to, but they may. They may say the construct, if it is the structural engineer, he can say, okay, if you have that floor with that load, you can make it half so thick, it's strong enough. That kind of remarks. Or if you see there's a hole, and the guy who's responsible for the pipes can say at this moment, I don't think I can all my pipes get through this hole. Please make it a little bit bigger. He's not obliged to do what the common says. He can do with it what he wants. But what happened then in this case? All people are now involved in the total project. So that's an advantage, gives people more fun, because it's nice to know everything. And the second, for the project, it's an advantage. This way, you use all the knowledge available in your product. These people are there, why not use them? And, normally, a document goes up to one company, a number of, and has to be distributed in the other one before it comes to the other guy, and then he can react. Reaction goes up again. Now it's a matter of just emails, phone, everything. And this is also a perfect balance between informal communication and formal control of the process, because you know the state where the document is, and everybody knows what he can do and not can do with it. And these roles are different. For example, I mentioned the structural engineer. In the next step, the structural engineer is a reviewer. Now he has another task. Now he cannot say, I think you can make it half, and such kind of remarks. Now he has to judge about, is it stiff enough? Do I agree with it or not? He can say yes or no, and why he does yes or no. So it's quite a different role in the observer state and in the reviewer state. And in the observer state, the guy is still working on. He just proceed his work. In the review state, he's not changing anymore. He has to wait until comments on until it, and then look at the next iteration, next version, etc. But if they don't approve, then the document goes back to him, and the state goes back from under review into in work. And that's different with the thing now. If you have draft and final, it doesn't fit you anywhere. It's just a funny, just a funny thing. Okay, another guy who's coming in. This is placed here not by me, but by Mr. Guest. He said because the integrity of documents is so important. This guy is only watching and looks to or the whole process. Everybody did what he's supposed to do. If not, he just returns the work, and the work has to be redone, and or the procedure has to be redone, etc. Otherwise, next. And then there is the authority that released the document, and the whole thing is under supervision or owned. The whole process is owned by the configuration manager. So this is then this is the proposal for a release process. Concurrent engineering. The first, because here we have a kind of concurrent engineering. They all look together to the same work. It's what I call a mutual involvement in the project. So that's concurrent engineering. What also can happen is look to a BIM model, an ideal BIM model, where all disciplines are working together in one model. I didn't see it so far, but suppose then people are on different locations, in different disciplines, not on the same moment, but working in the same space, in the same model. That's that point. That's also a matter of concurrent engineering. The other thing is that you have activities on the same time, or synchronous, in different phases of the life cycle. So one is still working at engineering, for example, this door, and the other one is already working on the tools to make this door. And this is the general mindset of concurrent engineering, doing activities parallel. And in the eyes of many people, this has only advantages. You gain time by doing things parallel. Yeah, that's not true. We saw the example. It was pity, but the geometry was still changed. And so the tool had to throw away and the time was lost anyhow. So we have to realize, if you talk about this type of concurrent engineering, you always work with advanced information. Yeah, it's still not finally released. So there is a risk of change and a risk of losing money and time. So, and that's why I say the following: you're working. Concurrent engineering means it's structural, embedded in the program or the project. And to go back to the earlier example, what happened to get this tool already done? People from manufacturing went to the drawing office, saw this drawing, and went away with it because they want to speed up the process, and if they are too late, they always have the black speeder. So they did it, and the consequence was that when there was a change, this 80,000 guilders had to be paid by manufacturing. Now this is not the real thing. What should have happened, it should be known by the program management that it takes so many months to get this tool, and they should weight the risk. What should we do? Let ordering the tool or waiting a little bit longer, and the risk was not for manufacturing, the risk was from the budget from the program or project. They should have thought about risk, they should have taken the risk or not. And only if it is in that way, I call it concurrent engineering. So we have mutual involvement, we have working together in the same model, and we have as a third working in different life cycle phases, 2, 3, 7, 6. And this concurrent engineering, except the first one, this costs you nothing. This is earning nothing because you have a lot of iterations in the front of a process, and it costs you nothing. But all the rest is working with risk, so you have to wait and take your decisions. That's what I want to say about concurrent engineering. So it's no easy thing. It's not an easy thing to do. You have to really think about it and put it. Okay, the change process. Okay, all the cliches is, you know, it's very often a disaster for the project, and this is coming also out in relation with flexible projects. We have two kinds of changes. The positive ones, improvements, the whole thing is delivers an added value, or the negative ones, rework or corrective actions. And that's what we want to avoid. Okay, let's think a moment about the change process itself, just in the form of steps. What has to be happened for a change? From somewhere in the universe comes a request for change, coming from the client, it can from workers, it can come from anywhere. And this request for a change has to be transformed into a technical change proposal for the product, or if you look to the business, for a procedure or whatsoever. So there comes a technical proposal, and not only a technical proposal, but also a financial attachment. What are the financial impacts? What are the impacts for planning and schedule, etc., etc. So there comes a complete proposal. What has to be done for the change? Just the proposal, not the change itself. And then the next step is we need to get a decision. Should it be done or should it be reacted? Okay, that's a management decision. That's a board decision, special board. We come later to that. Next thing is we have to have a formal implementation plan for the change, and this implementation plan should look to in everything what has to be changed, what as a consequence for this proposal. It has also to look for what is the real situation in the project. You can want to have a change, but all the people who have to do it are occupied for a higher priority. It makes no sense to make a short date or put the activity close. All these things have to be in place. So the planning is a separate thing that has to be happen. And the implementation will be written down in an order, and from this general order, individual orders are determined for the engineers who has to do certain job. Okay, the requirements then, or documents, documents are changed, and the next step is to realize the new physical objects. And then we have to look on the conform, etc. So these are the steps we have to do. And what do we want? We don't want to have many change processes. We want to have one clear change process without any gaps, just following the routines, and everything will become fine. This one. Okay. So this is it. In the picture, we see the current versions of the documents coming from the database. Problems, ideas, etc. come from everywhere, and this is the guy, the configuration manager. He gets, it's a very difficult function. He gets all the ideas. He checks, or if it's something that might be, if problems, ideas come from everybody, it can be something where that's already on the way. It's done by somebody else. It's about the same, etc. He has to decide, or it will be a fast track, meaning passing the board and going the fast way. And the fast way, if you go to the board, these are 2-3 persons that can decide about everything. Now these people come together once a month, not every day. So, and this if you take the fast track, you have a very simple process. Everything is done by the author and one of the an assigned user or one of the important users. So you go slow, but it's the same process, and it's still under responsibility. So it's a delegated task under responsibility of the board. He decides which route the change goes. The MFT stands for multifunctional team. That can be one person, 2 person, or more, depends on the complexity of the change. If it's only change a line on a drawing, it's with the speed of the system you can go through everything. And if it's a very complex thing, yeah, it needs months to get all the things done. That's his role. If the board decides yes and gives a priority, it goes to the planning. Planning is done, initiated by one single guy, and the decision is taken by the change implementation board. It's a board where all the practical people are and know about the situation in the field, etc. Here comes, and then the engineers get an order to change their documents. They go into the release process, and the new version goes into the database. We see here 3 forms: the ECR, Enterprise Change Request form. In fact, that's the form where the proposal, with the proposal, it's 184 with some standard answer and a lot of attachment with all consequences, etc. We have the next form, that is the ECM. That's the order that things will change. There's all kinds of IDs are on it, all kinds of the documents that have to be changed are on it. The effectivity is per engineering change node. You have one effectivity. This is the way they arrange it. One closed loop process, no gaps, nothing. It's just do it. And it's in the concept. It's worked out until the last forms and what you should do, etc. So and that's for industry. For building and construction, what you need is using the head of the experts and try to arrange it, to rewrite it with their practical things. Project organization. What I did here, I have built for everything, the processes I talked about. I've built a demonstrator in a PLM system, and in this demonstrator I had every company in the consortium was modeled as a manager and someone who does something. And so that's the reason why I have managers here with dummy names and engineers with dummy names. And that was the reason is that I had to model them in a PLM system like real persons. And if you do some work, you can you give people roles and they can play it. So this is more the conventional thing. You have a client, you have a project manager, a design leader, and a number of parties they control, hopefully. So what I did, I made, and this is explained more in one of the publications I give to you, I proposed a new organization for a BIM environment. What we recognize still the old organization. I put a volume manager here. We call in Holland a volume manager. International, they call this guy an area manager, but the word area was in Holland occupied by so many other things. So I took volume manager, and the volume manager is a guy that is responsible for placing and fitting of any component in a given space or space envelope. That's my volume manager. So this doesn't come from CMT, this comes from my IPM way of working. Here we put the...
We should finish in like 2-3 minutes.
Okay, so few remarks. The configuration manager should, in fact, should be in the line. Because what are we doing in a design engineering process? We produce documents. That's the primary process, and therefore this guy should be in the line. But that's one bridge too far for the moment, so it's put it in the start. You can read further things in the notes. What is your number? 5:45. I go a little bit faster. All these functions I talked about, all these processes can be done at least in the high-end PLM systems, and you can automate it in a way that you can connect to a BIM information server and do all these things, add BIM models and delete BIM models automatically. But I'm not a programmer, I don't know how to do it. And this is just available. A BIM administrator is easy to design, and he gets this moving baseline, and he can do on the effectivity dates, he can just add and subtract and delete piece of BIM models, and the result is an always up-to-date BIM model. This can be done. Now this afternoon is a little bit late, but tomorrow you can do this. So you can just go on. Fast actions already said. That's when you have a small changes not impacting on cost or schedule or what so much. And if you have a mature implementation of configuration management, 85% goes along the fast track, and only 50% goes through the board. But it's the same look, the same process, nothing. So big advantage is also that you have the right priorities in your schedule. If there are any questions, you know to find me. So don't hesitate if you have some questions. Just mail. The verification process. A work authorization, you realize the project, and you have NCR, the last form, non-conformance report, and also people, they don't like all these things and changes, so they know the aspect of waivers. So okay, it's acceptable, do it. Don't get loose in this type of things. Even aerospace does it as well, but try to follow the policy. A requirement first, the logistic, the thing follows, the object physical object follows. Conclusions, and of course I hope you agree with it. I have presented a complete process to accommodate change, complete with verification, without any gaps that need to be bridged by informal communication, and eventually, that's not from today or tomorrow, but we really get rid of corrective actions and rework, and so reassuring real flexibility. Okay. There you can find everything back. Everything, everything. And if you have questions, say it again, just mail.